nutrients, and fertilizers. The human body is made out of chemicals that come from the food that we eat. Digestion is where our body breaks down the food we eat into smaller molecules that can be used and absorbed by our bodies. Smaller molecules are more soluble and can pass through membranes from our digestive system into our blood to be transported around and used by the cells in our body. Our cells use these nutrients for energy, growth, and cellular repair. Nutrients are made up of elements and compounds and help living organisms like us survive. Organic and inorganic nutrients exist. So types of compounds our bodies need are both organic and inorganic. Inorganic compounds are substances that do not contain carbon. Inorganic compounds do not break down, whereas organic compounds do. Organic compounds contain carbon and mostly oxygen and hydrogen. They sometimes contain some other nonmetals, but mostly these three. They come from living things like plants and animals. And the organic nutrients are classified into 4 major groups: carbohydrates, proteins, vitamins, and lipids, or fats. So the first one is carbohydrates. Carbohydrates are our body's main energy source for metabolism. They are plentiful or present in sweet and starchy food. So we are trying to aim to have about 60 to 65% of our diet be carbohydrates. These would be rice, grains, bread, fruits, and vegetables. Organic nutrient number 2, proteins. So these help to build our body's structural molecules and help repair cells. We want to aim to get about 30 to 35% of our diet as protein. Protein comes from meat, eggs, nuts, dairy products, etc. Lipids, or fats, are our body's energy storage molecule. We can store fats to be used if we don't have a source of carbohydrates available. They also help to insulate and are really, really important for our brain function, making up a lot of our brain tissue. Examples are vegetable oils, nuts, fish, avocados, and we want about 10% of our diet to be fats, healthy fats. And the last one is vitamins. These help the body to maintain cells' chemical processes. Vitamins can be fat or water soluble, so this is how we would ingest them and where we would store them in our body. So vitamin A, D, and E are fat soluble, meaning that that's how we get them is through good fats or healthy fats. And because they are stored in fats, of course, our body has a coating of fat in our skin, but also it could be really important for some of our brain functions, because our brain relies on a source of fat. Vitamin C and B are water soluble, so they're more likely to come in through plant, like fruits and vegetables, and are stored in our cells. A lack of vitamins can cause illness, and the percentages we need vary depending on the vitamin we're looking at. Macronutrients are needed in large quantities. So what we say is a large quantity is greater than 100 milligrams per day or more. It's an essential component in enzymes and vitamins, so large organic molecules which can help the enzymes in our body function properly. The body cannot manufacture macronutrients. We can only get them from food. So green plants require 18 elements and humans need 25. Micronutrients are also known as trace elements within our bodies. They're also needed, but just not in large quantities, so less than 100 milligrams per day would be something that can be considered a micronutrient. So some elements in our body, this list is absolutely not exhaustive. There is one in our textbook in this topic 1 if you'd like to take a look. Calcium for nerve conduction, muscle activity, so specifically muscle contraction. Most importantly in our body, our heart. It helps to form bones and teeth. Phosphorus, again, helps with our bone formation, and it regulates our metabolism. Sodium regulates nerve impulses, the muscle activity, and our blood pressure. Potassium also regulates those nerve impulses, muscle activity, and protein formation within our body, so regenerating some of our tissues. Chlorine helps regulate our water balance, so hydration, sweating. Iron is part of our red blood cells that transport oxygen to cells, so our hemoglobin. And zinc helps to regulate protein formation. Note that we don't just need one element sometimes for some of these processes. So for instance, muscle activity came from calcium and our sodium and potassium. We had zinc for protein formation, same with potassium. So we need both elements. We can't just have one. If there's too many or not enough nutrients, it can have harmful effects. The optimum amount of nutrients results in the best health. Taking medication can affect chemical reactions going on in our body and can correct a chemical imbalance. They can relieve symptoms that are present because of not having the optimum amounts of chemicals you need for good health. So we look here, we can see Canada's Old Food Guide and Canada's New Food Guide. How do they differ and what are their similarities? Well, I can find fruits and vegetables on both. I can find grains on both. And I can find meat or protein on both. However, our new food guide no longer recommends a number of servings per day. It simply tries to state that half of what we eat should be fruits and vegetables. A quarter of what we eat should be a protein, whether that is meat, maybe some dairy. This looks like maybe some Greek yogurt, or meat alternatives that also contain protein, like tofu, beans, legumes, seeds, and nuts. We also see that the serving size is not defined. So whatever we are eating, whatever is healthy for us, because the amount that one serving looks like and the number of servings per day depends on who you are. My toddler, for instance, and I eat a different serving size, but we may also eat a differing number of servings per day. Given that I'm currently pregnant and he is a little guy, they would be a different number that we would be eating based on these food guides. So this one just had too much information almost, and we weren't necessarily following it. This simplifies things. Lastly, it encourages people to drink water. Rather than having milk as its own category. Oftentimes we would have thought that a glass of milk belonged here, but we need water too. We need to be hydrated so that we have good blood pressure, and our cells and muscles are working to the best of their ability. A balanced diet, again, is important because we need each of the organic nutrients we've talked about, and elements could be missing from a diet. So even though some people eat quite a bit, they may not be eating from all of these nutrient groups. And so that could lead to an inability to digest the food that they are eating if they're missing some of these minerals. And it affects many of the different roles in the body. Again, because we need potassium and zinc for protein development in our body, we may be missing one and therefore missing out on some of those healthy protein developments. Healthy eating is not just about what you eat. So being mindful of our eating habits, so how we're eating, what we are specifically eating, where it is that we are eating, when and why we are eating. So eating in the car, on the run, in front of the TV versus sitting at the table and eating. When we're eating, are we snacking at the end of the day versus skipping breakfast? Why we are eating? Is it because we're hungry or because we're bored or because it looked good? Need something to do? Cooking more often at home rather than ordering in, going out, helps us to avoid processed foods. Enjoy our food, kind of eat slower, I think is that idea there, and eat with others, make it more social. Read the food labels, it's really important. So we want to limit foods that are high in sodium, sugar, and saturated fats. We want to be aware of food marketing, so trends, brands, promotions, etc., that are trying to grab our attention. So for instance, we can think of pop advertisements, trying to really brand themselves that we're going to choose them when we go to the store for something to drink. So where do we get our energy? We get energy through cellular respiration. So cellular respiration is how our cells get all of the energy they need to carry out the processes. All of the foods that we eat are digested into glucose, so a sugar. And what we know is that glucose and oxygen in our cells come together in the mitochondria to make carbon dioxide and water and energy. And this energy is what our cells use for all of the processes they undergo. And the CO2 they produce is returned to our lungs and we breathe it out. Photosynthesis is how plants take energy from the sun and turn it into chemical energy. So the chemical energy plants produce is glucose. So they make glucose through photosynthesis. And this glucose can then undergo cellular respiration in plants to make that chemical energy for them. So plants take carbon dioxide and water and the sun's energy, and they make glucose and oxygen. This glucose can then undergo cellular respiration to produce cell energy. Most of the elements that we need to survive are found in the soil. This would be a problem if we were to try and extract them ourselves because nobody wants to eat dirt, but we'd actually have to eat so much of it to get the minimum amount of each element we needed. So we rely on plants. Plants extract the nutrients we need from the soil because plant roots have really tiny hairs, which increases their surface area, making this a much easier process for them, that are good at extracting minerals from the soil. These minerals become concentrated in the roots of plants and move up the plants. We eat them, we get those minerals. Yay, we didn't have to eat the dirt. So plants use these minerals or inorganic compounds to make organic compounds. So these minerals within the soil are used to produce the glucose that we need. Animals that eat plants use these organic compounds made by plants for energy, growth, and repair. And we get some of these inorganic compounds and vitamins along the way as well. By knowing how plants use each element, agriculturalists can diagnose deficiencies and excesses and act accordingly to alleviate the problem. So, for instance, yellow striping on lower leaves and a little soil test shows that there's high levels of potassium in the soil and low levels of magnesium. So what they can say is that potassium is interfering with magnesium, and so they're going to stop applying fertilizer that contains potassium, and we're going to apply more that has magnesium to kind of fix this problem. Now, of course, if this was just like a house plant, it wouldn't be a big deal, but if this is happening to an entire crop, a farmer may lose those plants, and that would be a problem. All right, so let's take a look at some of the important elemental nutrients and where they're found. So oxygen has the symbol O. Oxygen, if you're looking at page 182 of your textbook, it says that approximately 49% of the earth has is oxygen, or 49% of the elements on Earth are oxygen. In a plant, approximately 75% of the plant is oxygen. And within the human body, 65% of our body elements are oxygen. A lot of this we could probably attribute to water. Because water has the composition H2O, I'm going to go out on a limb and guess that the majority of the oxygens that we're finding in plants in the human body and in Earth are trapped in water. We, of course, also have them in the atmosphere as like O2, the gas, but a lot of it would be water, is my suspicion. Carbon is up next. Carbon is C. The approximate percentage in the Earth's crust, so the ground, is 0.09%, so not even 0.1%. However, in a plant, it is 13%. So we can see here that the plants have absorbed more than what is readily available. All right, so the concentration in a plant is higher than the concentration in the Earth. In the human body, the percentage of carbon is 18%. Again, these would come from mostly proteins and sugars. Hydrogen, its symbol is H. Its percentage in the Earth's crust is 0.88%. The approximate percentage by mass in a plant is 10%, and in the human body is also 10%. Hydrogens are likely coming from the water, the proteins, and the sugars that we were just talking about. Nitrogen symbol is N. 0.03 of the Earth's crust is nitrogen. And the approximate percentage by mass in a plant is 0.45% and 3.3% in the human body. Sorry. And last but not least, let's look at calcium. There's a bunch here in your textbook, but we're just going to look at these 5. So calcium's formula is Ca. 3.4% of the mass of Earth is from calcium. 0.07% of the mass of a plant is calcium. And 1.5% of the human body's mass would be of calcium. Let's take a look at fertilizers. Fertilizers are really important for plants to get a few of these particular elements. So the elements we're looking at here are nitrogen, phosphorus, and potassium. And they're always reported in this order. So if you see the numbers on a bag of fertilizer, you're looking at the percentage by mass of these elements, within that fertilizer. So, and of course is nitrogen. Nitrogen is good for leaves and green plants. P is for phosphorus. It's good for strong stems. So for trees or think of a sunflower, it needs a really strong stem to support itself. Potassium is good for roots and flowers. Your flowering plants or ones that develop a large root system. Now, we can't just give one or the other. We usually try and give a balance, and whether it takes more of one or another is fine, but different applications, of course, but we're usually applying some amount of nitrogen, phosphorus, and potassium in all fertilizers. Plants need fertilizer because they cannot take enough nitrogen out of the atmosphere for their plant growth. The other percentages of the fertilizer will have some micronutrients and fillers. So the percentages that are listed here are not going to add up to 100, and that's because there's some other compounds there just to fill up the gaps. So some issues with high productivity crops. So we've used fertilizer. We have a great high productivity crop. What are some of the problems? So more land is used for crops because we can supplement the soil with our fertilizers. More water is then needed because we have more land being used for crops. And there's a drastic increase in the amount of fertilizer that's entering the environment. The number reported in your book is 140 million tons per year. And that is, again, because we're choosing other locations that may not have been completely suitable and using fertilizer to kind of beef up the soil. So chemical agents used to protect the crop, like pesticides and herbicides, also reduce the amount of damage, but they're costly and have harmful effects on the environment. Another issue with the high productivity crops is an increase in the spread of disease. So if we plant only one crop and a disease begins in that crop, it increases the chance that it's going to spread through the entire field or crop. So we would wipe out one crop with this disease. Therefore, a variety of crops allows for some to become resistant and thrive throughout. And lastly, crop production is doubled worldwide due to the use of fertilizers and high yield varieties of plants, which is great. But we need to consider and weigh these pros and cons. To practice, don't forget to complete the learning guide for this topic. There is always extra practice in your textbook at the end of each topic if you're looking for it as well.